Morning, Anna.
Good morning, Professor Richard.
How are you doing?
I'm good. After my test, I'm good.
All right, fair enough.
Yeah, it's too much work, and you need to really pay attention and be careful with the numbers, why you multiply, why not. And, I think it's many things you need to have present in the moment you are working with this. And but I did, finally.
All right, we'll get started in about a minute and a half.
Okay, cool.
Morning, Kayla. All right, can you see my screen?
Yes, we can see.
Good, thank you. All right, it's 10 o'clock, we'll get started. So what I was going to focus on today was the second part of test 2. Last Monday we did the naming portion. Now we're going to do the chemical reactions portion, probably the more difficult portion of the two. And we'll start out with these questions here. It's good to go from 11 through, looks like 14, 15, 16. Okay, 11 through 16, where we're talking about the different ions that are present in solution here. And for something like this, for number 11, what I would do is I'd look for the thing that actually had OH in it. And you can see that's going to be the MgOH2. And what I would do is I would draw a picture of what that looks like. And then you can see it's going to be Mg2 plus and then 2 OH minuses. And of course the OH minus, we know what the charge is by looking at the polyatomic ion sheet, which is right above the question. So you won't have any trouble finding that. But again, you're only focusing on whatever has the OH in it because all the questions have OH in them. Okay, looking at this one here, we're looking only at the one that has CrO4 in it as an ion. So again, I would draw a picture of it. So 2 H's, CrO4, the charge on that is 2 negative. Again, I get that from the polyatomic ion sheet, CrO4, 2 minus. H plus. Does anybody have any questions so far?
No, I think this is really clear. When you draw the, when you draw the equation, you can see literally what is the charge and
All right, so for the next one, same deal. 3 Cls, 1 CO. The charge on Cl is going to be -1, 3 plus. Remember, you're only interested in the charge on one of these. Just likewise over here. Because it does say in the question, one of the single ions on the reactant side of full ionic equation is. So we're looking just for the single ion here. because these are, when this breaks apart, it does break apart into Mg2 plus and then 2 OH minus atoms, and they're separate. So OH minus ions, and those are separate ions. Likewise over here, it'd be CO3 plus and then 3 Cl minus separate ions. And that's the important thing to note, I think. So for this one, again, same kind of deal. We've got the one with is this PT compound, and if I drew a picture of it, it'll look like this. That's going to be 4 plus because that's minus, 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 and minus, which makes the ion there, the one I'm circling, the NO3 minus. This one here, it's a CaCl2 that we're interested in. So Cl minus, and Ca2 plus. And, you know, we can always get, for those kinds of ions like Ca, it's in group 2, so we know it's 2 plus. But we also know that chlorine, here is in group 7, so it's 1 minus. But the thing is just to get the charge on one of those, and that's the ion that will be the answer there. Okay, one more here, the charge on cobalt. So we've got 3 NO3s. We know that each of those is a -1 off the polyatomic ion sheet, so that's -3. That means it has to be +3 to match it. So again, the charge on the cobalt will be 3 plus. And that'll be your answer there, +3 or 3 plus. That one there. All right. Any questions so far about any of those?
No updates.
Okay. Let's look at balancing here. Whoops. I'll go through this one as an example. Now, some of this might involve a little bit of trial and error when we're going through this. So what you would probably do is look for things that aren't balanced initially. So we've got 4 carbons here, only 1 over here. The other thing I would look at is try and focus in on things that only appear once on each side. That looks like it's the case here anyway with all of these. So that makes it a bit easier. I tend to try and leave oxygen till the end. So that's just as a general rule. But I would put a 4 in front of here for the carbon. And we've got 4 hydrogens here. I'll put 4 in front of here as well. You can see that balances the H and the Cl. And now that we've got 4 carbons here, we've got 4 oxygens. So put 2 in front of here, and that would balance it. Now, the sum of coefficients, you have to include this 1 here as well, which we usually don't write, but it's still there. So it'd be 1 plus 2 plus 4 plus 4, which would be 11. And that's how I'd manage that. Any balancing questions there? Okay.
No update.
So for this next one, there's actually 2 possible ways that this can go. Now for this one, we'll just go ahead and balance it, but I'll show you another example that's of a slightly different type to this. So the way we handle this is we've got 9 carbons, so we've got 9 carbons here. We've got 20 hydrogens, so I'll put 10 out the front here. 10 times 2 is 20, so that balances the hydrogens. Then we can look at the oxygens. We've got 9 times 2 is 18, plus 10 is 28. So there's 28 oxygens on that side. And we've got O2 over here. If we put 14 in front of this, that will balance it out. The sum of coefficients, 1 plus 14 plus 9 plus 10. So 15 plus 19 would be 34, would be the answer for that one. Now, the way this works out, see, if you take 20 here and you divide it by 2, you'll get 10, which happens to be an even number. That's how I know I'm not going to have to end up multiplying this by 2 at the end. But if I had something different, like C9H18, for example, things become a little bit different. So you see I've just changed one of those numbers here. Now, if I take this 18 and divide it by 2, I get 9, which is an odd number. So you'll see what effect that has. So I go ahead and I put 9 here, and then I put 9 here, because I've got 9 times 2 is 18. And now if we look at the oxygens, we've got 18 plus 9 is 27, which isn't even. So I have to balance these oxygen O2s over here, I do 27 over 2, which means that I need to multiply everything by 2 to get rid of that fraction. Now understand, I knew I was going to have to do this because when I looked at the hydrogens and I divided them by 2, I got an odd number. Whereas over here, I got an even number. I didn't have to multiply that by 2 at the end. It's because you end up getting an odd number of oxygens, and then you need to be able to balance that by doing a fraction. So that means it necessitates putting a 2 in front and multiplying it all out. So the sum of coefficients, 2 plus 27 plus 18 plus 18. So it comes out to be a pretty big number for that one. All right, does anybody have any questions?
No, this is clear.
Okay. All right, so moving on to these kinds of problems. These are the ones that people begin to have some hassles with. So we've got LiOH and H2CO3, and we're told that we're getting a compound A and water as a formula here, and we're looking for the formula of compound A. So what I like to do here is I like to show what each of these looks like as pictures. So we've got Li and OH, and we'll have Li plus and OH minus. And we'll have H plus and CO3 2 minus over here. Now we know that we're getting water as a product here. So we're getting this compound A plus H2O. The H2O is as a result of combining the H plus and the OH minus. Now at this point, students often get confused and they say, well, what about this other H plus here? Why aren't you combining that to form some other magical compound like H3O or something like that? I mean, to make it balance. Well, the thing is that I'm not really interested in balancing the whole thing yet. All I'm interested in is balancing the compounds that I'm going to get here. And what I'm interested in here is the balancing of H plus and OH minus. That provides me with the water. Now this compound A here is going to be the combination of Li plus and CO3 2 minus. And in order to make that a valid compound, I have to make it Li2CO3. Now I know what some of you are saying. You say, well, can you just pull that second lithium from out of the air and just put it there? Well, the thing is, at this point, all I'm interested in doing is balancing these compounds. And then at the end, I could possibly balance a reaction. That would give me my answer that I need for this specific question, which would be Li2CO3. And you can see it is there. But if it wasn't there, you'd have none of these. And if I did want to continue with this problem after this, I don't have to with this specific one, then what I could do is I could balance it. I could look at it this way. So LiOH plus H2CO3 gives Li2CO3 plus H2O. And to balance that, I'll put a 2 in front of the lithium like that, and 2 in front of the H2O, and that would actually balance it out. So we've got 2 lithiums, and the oxygens, we have 2 for the water here. We'll have 1 CO3, 1 CO3. And the hydrogens, we've got 2 hydrogens here and 2 hydrogens here. That's a total of 4. So that would balance. So that's when we take the other hydrogen into account, is at the very end, when we're actually balancing the reaction. So the message I'm trying to send here is balance the compounds first. And then balance reaction. But in this case, you don't even need to do that second step because you've already got what compound A happens to be. It's always going to be a neutral compound, but keep in mind, you might have to add some things in order to make it balance out. All right, does anybody have any questions about number 19?
No, please.
All right. Kayla, are you doing all right? I suspect Kayla might not have audio. So let's look at this one here, KOH plus H2SE. So we definitely know we're going to get this compound A plus H2O. We've got K plus OH minus over here for this one. We've got H plus, and Se2 minus over here. Now I know that the charge on Se2 minus, the Se is 2 minus for 2 reasons. First of all, so Se is in the oxygen group, so that's all -2 on down that way. The other thing we know is that we've got two H's, they're both plus, which means that has to be -2. So we know that the H plus and the OH minus are going to join together, and that's going to give us the water. But now I have to figure out what's going to happen with the K plus and the Se2 minus. And in order to make that work, it would be K2Se would be the answer there. So I'd need 2 Ks to balance out the -2 on the Se. And again, I know you might be saying, well, where'd you get the extra K from? Remember, we're only interested in balancing the compounds at this point. We could balance the reaction later to make that work, but presently all we're interested in is figuring out what A is. Whatever's on this side is always going to be neutral compounds, and you're going to have as many as you need in order to make that work. Does anybody have any questions?
Yes, Professor Richard, I have one.
Mm-hmm.
For example, when you have, can I tell you the example?
Yeah.
Okay, so it's a
I'll
W.
write it down here if you like. So what is it?
W, parenthesis, OH, close parenthesis 2, plus H3, PO3.
Okay, that's a good one. I like that. Okay. So we're definitely going to get water as a compound here, right?
Yeah, this is a little bit confused because when you are working with the charge, both have 3.
No, no, they don't. No, they don't. See, the W here is 2 plus, and the PO3 is 3 minus. See, the W has to be 2 plus because we've got 2 OHs there. So they're each negative, so the W has to be 2 plus.
Yes.
So what we're working with here is the H plus and the OH minus. Yeah, that works together to give the water. Now the W2, I'll put this up here, W2 plus and the PO3, 3 minus. Those combine together to give W3, PO3, 2. So again, the essence here is we've got 6. So each of them has to add up to +6 or -6. So to get +6, we need 3 Ws. to get -6, we need 2 PO3s.
Okay. So the charge in the beginning will be, okay.
It's always going to be based on the OH, which you remember in this kind of problem, you're always going to have OH as the negative on one side, on one compound. You always have H plus in the other compound.
Yeah, this is a little bit confused because when I work like a B, C, D, right?
Yeah.
So the middle will be a water, right? But I work with A and D. So I think the
Well,
chart with W will be 3 plus, but it's not.
no,
Yeah.
because the charge on the W is always going to be determined by how many OHs are with it.
Okay, yeah.
Always,
So you need to
right.
work it first with the chart, and
Mhm.
after that you need to
Yeah.
compound.
If you
Okay.
do that, then you'll have a much easier time of it, Anna. Morning, Ashley.
Good morning. Sorry I was late. The girl that was supposed to cover for me didn't, and I got off work extremely late. We had a code. Sorry.
That's okay. All right. Did you have any questions about this one, Ashley? I know you kind of skipped in a little bit late with it. Yes, this one here, the KOH and the H2SE.
I know you eventually post the like the Zoom. Is this one of the questions I had was about that chart, the aqueous and that yellow and blue chart? Is that what you're going over?
Well, we don't really need that right now. In fact, you don't even really need that for the test at all.
Okay.
I haven't gotten to that point yet, Ashley. But I'll probably bring it up at some point.
Okay.
But as it turns out, I'm never really going to ask you on the test about soluble and insoluble stuff because it's already given to you. Okay. Any specific questions about this one here, Ashley? Number 20.
I just kind of popped into it, so it would be unfair to ask a question because I just kind of. I mean, do I know how to do it? No.
No. Okay. Well, I'll tell you what. I'm going to re-roll this,
Okay.
and I'll go back and we'll pull up another question. Okay, so that everybody can benefit from it, including you.
Thank you.
So I'm just going to restart the quiz here again. I won't go back and look at the ion things. I'll get you to look at the Zoom thing for that. These are the ones that are harder, I think, the ones that I'm going through right now. Okay. All right, let's look at something like this. This is a good one. I like this one. So you can see that we get the compound A and we get water as well. So what we do is we take our compounds here. And we know we're getting A plus H2O. We draw these out. We're always going to have OH minus and we're always going to have H plus. So if that's H plus, that has to be I minus. If that's OH minus, then that's going to be -2, which makes this +2, which makes the copper +2. We know that the OH minus and the H plus combine to give water. And we know that the copper 2 plus and the I minus will combine to give us our other compound. And that would be CuI2. So I imagine, Ashley, one of your questions is going to be, how can I just combine the OH minus and the H plus to give water when I've got this extra OH minus here? Does that bother you?
Yes, it does.
Okay. Well, what you've got to understand is that in this specific step, all we're doing is trying to get balanced compounds that are neutral, compounds where you get the positive and the negative balancing out. It would only be at the end that we would account for those extra atoms by balancing the entire reaction. So you have to leave that go. It's like down here, one thing I think bothers you here is, where do I get this extra I from? How can I just pull that out of the air, right? Does that bother you?
Sure does.
Yeah. Well, the thing is, again, all I'm trying to do is get a balanced compound here. So once I've got that, now that's all I'm really interested in for this question. That would give me my answer. But if I wanted to continue with this and actually take account for what I've done, it's then that I could balance the reaction and have 2 in front of the HI and then put a 2 in front of the H2O, and that would balance everything out.
So this is not focused on balancing in this particular...
Not the entire thing, no. All we're interested in is, well, what's compound A?
Okay, so to do that, you have to, draw it out like you did.
Mm-hmm.
Then, because here you took the OH negative and paired it with the H negative?
H plus.
Oh, that's a plus. Okay, so that makes sense. Is there a reason why you paired those two particularly together?
Because I know that I've got water as a product here. Ashley, do you see that?
Okay.
Yeah, that's how the water gets formed. It's from the H plus and the OH minus combining together. But then I have to look at what's left. I got the Cu2 plus and the I minus. Then I have to ask the question, well, what would I have to do to make that a neutral compound, a balanced compound? And that would be to make it CuI2.
Yeah, because there's only one. Okay.
But the hardest part of this is looking at it and saying, well, hang on, how do you pull that extra I out of the air? I mean, it doesn't look like it's there for you to use. Well, that's just because you haven't balanced the entire reaction yet.
And we're not trying to balance it out yet, but if that was the goal, then you would continue to balance it out.
Yeah. Yes, if you wanted to, but we're not required to do that. All we're interested in here is, well, what's compound A? Compound A is always neutral. It's always a neutral compound. Is that okay, Ashley?
When you say neutral, can you
well, neutral, I mean positives and negatives balance out. See, this is 2 plus and I minus. That's clearly not neutral.
Yes.
Because the charges don't balance. So you need a situation where the charges balance, which means we need 2 I's to make that happen. So if I drew a picture of that, you can see that it's neutral. And what I mean is, that's -2 and that's +2. So if the positives and the negatives match, then it's a neutral compound. By neutral, I mean it has no net charge on it, because the plus and -2 balance out. Is that okay, Ashley?
Yes, sir.
Okay. I'll tell you what, all 3 of you who are here, I'd like you to, well, this one's a little bit too similar to the one we just did. All right, I'm going to give you another example, and I'm going to get you guys to have a go at it and make sure you understand it. Okay, let's see. What's a good one for me to do here? All right. Let's see. Oh, yeah. Okay. Okay, let's do that one. So the products are this compound A plus water, and your mission is to figure out what compound A is. So I'd like all 3 of you to try that. And we'll see how you do. This will really make sure you understand what you're doing. So the first thing you should be doing is just drawing them out and then putting charges on and then figuring out what combines with what.
Doing that now.
Okay, you want me to wait a second, Anna? I'll wait a little bit.
Yeah, just give me like maybe like just 60 seconds so I could like
Okay.
just think, I guess on my own.
Let me know when you're ready, Ashley.
All right, so I have 1 CR, I have 3 OHs.
That's good. What's the charge on each OH?
It's a negative.
It's a -1, yeah. You can get that from up here, from the polyatomic ion sheet, OH negative.
Okay.
If ever you forget, but it's always going to be OH negative. What's the charge on the chromium, Ashley? The CR.
Positive?
Positive what?
3?
Yep, that's right.
Oh, you're writing it. I'm sorry, I was still looking at my paper. Okay.
And the HBr splits into H plus and Br minus.
Yes,
We know that these two combine to give water.
I got that.
And then you got your Cr3 plus and a Br minus. See, that doesn't balance. That's 3 plus and that's -1. The only way I can make this balance is to have 3 Brs. So it'd be Cr, Br3. That would be my answer for A. So what do you think of that, Ashley? That last part.
That helps. That helps a lot.
Okay, now here's what I'd recommend for you, Ashley. I would recommend you do this practice test again and again, just focusing, a bunch of attempts on specifically those questions 19 and 20, and do them until you're getting the right answer consistently.
Okay.
And if you follow that same path as I just did here, making sure that at the end, you're combining them correctly so that they balance out the charges, then you'll be fine. That last step is the most important step. Are you okay with that? The CRB, how I got the CRBR3 from CR3
Yes.
plus and BR minus?
Mm-hmm.
And if you do that, then you should be okay. We're going to do some similar ones to that in a minute as well. So don't be afraid. We're going to continue with this. Like these ones here, number 21. Now, the ones we just did with the H plus and the OH minus are a little bit easier because we know we're always getting water as a product. But here we're getting two separate compounds. I do like this example here that we're going to do. But what I'll do is, it's only asking for one of these, but I'm going to show you how you can get both of them, both the products here, and what those products look like. Okay, so we've got CONO3 2 plus K2O. So we would draw out what these look like. It's going to be very similar to what we just did. So that'd be NO3 minus, and then 2 plus. And again, the reason we know cobalt is 2 plus is because we have 2 negatives on the nitrates in total, which means we've got 2 plus on the cobalt. We'll have K, and O. O is 2 negative, K is 1 plus. Okay, any questions so far? So what's going to happen here? We're going to have the cobalt combine over here with the oxygen, the O2 minus. We're also going to have the K plus combine with the NO3 here. Now notice how I only took one of each here in order to make that happen. So we've got CO2 plus and O2 minus, which produces COO as the compound. And then we'll have K plus and NO3 minus, which will produce KNO3. So the thing here, and it was very similar to what we just did, you're just taking one of each to balance them out. Remembering that the whole thing will end up being balanced if we balance the entire reaction at the end. So the answer here would be COO, be this one here. Does anybody have any questions about that? Let's look at number 22. Do you all want to try this one yourselves? Ashley, do you want to try this one? Or do you want me to do another one?
Yeah, I'd love to try it on my own.
Okay, let's take a couple of minutes here to try this one. I'm just going to write down the question. I'm not going to do anything yet with it. Now, I'm going to take it one step further, Ashley. I want you to come up with both. I want you to come up with both here. This goes for you too, Anna and Kayla, if you're following along. See if you can come up with both compounds that we're going to get from this. Yeah, I like this one. This one's a really good one to do. It really sorts out all the difficulties. You'll see that. So remember the steps here. Draw out what they look like, put the charges on everything, and then just combine one of each and come up with neutral compounds and see where that leaves you. Obviously, if you're watching this on the Zoom session, you can always fast forward until I start the explanation here. That's one benefit of watching the Zoom, I guess. Just let me know when you're ready, Ashley.
So I have CR drawn out. Then I have NO3 minus, NO3 minus, NO3 minus.
That's good. What's the charge on the CR, Ashley?
3+.
Plus 3.
That's right. And have you got Na, and O on the other one?
I have Na, and then an O.
Okay, what are the charges on?
And an O. Yeah.
What's the charges?
The charge is going to be O negative.
No, let's look at
Oh,
where O
negative.
is.
Yeah.
Let's look at where O is. See, it's in group 6, right? So it's
That's
negative
right.
2.
Yeah.
Negative 2. So this is -1 in this column. This is -2 in this column, Ashley.
Yeah, you're right. You're right.
So that's -2. This is going to be +1 and +1. Those are in group 1 as well. That's the other reason you know that it's -2 is because each of those is +1 actually, because that has to balance out. So what you can see here is we're combining one of these and one of these. That'll give us Na plus NO3 minus, which will be NaNO3. That's one of them. Now we're combining these two, which is Cr3 plus and O2 minus. Whoops. And that would be Cr2O3. So it looks like you did the first part correctly, Ashley. What about this part here, combining the two together?
It just seems like we've completely forgot about the NO and the Na.
Well, if you look at the answers, you can see that we're not looking for that. Oh, you say we've forgotten about a lot of them, or is that what you're worried about?
Yeah, I guess.
Okay. Well, the thing is, remember that at this point, all we're trying to do is figure out what these products are. We're not interested in balancing the entire reaction yet. So what we're interested in doing, and this is the main thing, you just take one of each and combine them together and see what you need, see how many you need. So that's why
I'm so sorry, go ahead.
That's why I took one Na and one NO3 and then combined them together and came up with NaNO3, and then the Cr3 plus combined with the O2 minus. And I know I need two chromiums and 3 oxygens to make that neutral.
I get that. I get that part at the end. So the answer is Cr2O3, right?
That's right.
Because you have to make a. Yeah, I get that part.
I mean, you could shortcut this a little bit, and you could say, well, that's Cr3 plus, and that's O2 minus, and then you could work it from there. So you don't have to do the whole thing, but I'm just showing you where it comes from. I mean, you can do it fairly quickly if you know what the charges are. All right, how do you feel about those, everybody?
That's good.
Okay, Ashley, do you have any? You okay with it?
I'm decent. I'm gonna keep working at it.
Okay, well, this is another one. Let's why don't we try this one together? All right, I mean, give it a go, and this time we'll just focus on the one with the actual answer. Okay, so just look for what I want you to do, Ashley, and everybody else here. Look for the charge on the platinum and the charge on the OH, and then come up with the compound from there. Just focus on that. So figure out what the charge on the PT is, figure out what the charge on the OH is, and come up with a compound. Don't worry about the rest of it.
Well, if that's the case.
Okay, what charge do you get on the platinum?
You will have 4.
Yeah. And the charge on the OH?
It will be negative.
Right. What would be the compound you'd have to make that balance out?
PA, PT, OH, 4.
Right. That'll be it.
Oh, okay.
See, we get the PT4 plus pretty easily. And then, I think it's really all about it's really about drawing the pictures, you know. The other compound, by the way, would be LiNO3, which would be the combination of Li plus and NO3 minus. Again, just one of each.
For my sanity, could you tell me why we have to put it in parentheses?
Because if you just left it like this, what you'd be saying is that there's 1 O and 4 H's.
Oh, that's right. Thank you.
So that would not be correct.
That's right.
But that is one of the answers, I think, as well.
It is.
Yeah.
I think I just saw it somewhere.
No, maybe not.
Oh, no. That's.
I should have included as one of the answers, though.
No, you shouldn't. That's not nice.
No, but still, I should have. All right. Okay, let's look at this one here. All right, so again, we're only interested in the combination of calcium and and Ca and Cl and see what we get there.
I'm just gonna go for it. You know, I don't mind being wrong. Ca.
Now we know Ca2 plus because it's in group 2, and this is 2 minus. We know that that's what it is from the polyatomic ion sheet. So we're just combining these two. It'd be CaCl2.
Oh, I got it right.
That's good. What would be the other one? What would be the other compound? That one's a little bit tougher, actually. Combining these two. What do you get for that?
Is that on the test?
Well, it's not. Well, it could be. It could be. I mean,
Let's see. It would be Cr.
Now remember what's going to be first. The Al is going to be first because it's positive.
It's positive. AlCr.
That's not right. That's not the right answer, by the way. I'm just preparing.
So.
How many aluminums do you need?
3.
No, you need 2. Because if you look at it, it's -2 times 3, that'd be 6. So we need 2 aluminums to get to +6. And then we need 3 CrO4s to get to -6.
Okay.
So that would be the other compound. All right, is that okay?
Yeah, that was a good thing to learn from just now.
Okay.
It's a learning process.
Okay. Lara, let's look at full ionic equations. This is one that usually people have a good deal of hassle with. But again, we're just extending the same kinds of concepts as we've been working on for something like this. So let's have a look. We've got Cu NO3 2 plus 2 LiOH gives CuOH2 and Li2 LiNO3. Now, what's going to also be important here are states. That's aqueous, aqueous, solid, and aqueous. And notice those are given to you. Now, why is this important? Now, the aqueous means that when you put it into water, it dissolves into ions. It splits apart. If it's a solid, then it doesn't split apart. It just stays as a solid. That's important. If it's a solid, it doesn't split into ions. And that's really the essence of what this problem's about. Now, what I like to do is I like to draw pictures of these to show how many ions I'm going to get. So if I'm drawing a picture of CuNO3 2, it looks like this, Cu with 2 NO3s. If I draw a picture of LiOH, 2 of them, that's what I'm going to draw, 2 LiOHs. The CuOH2 doesn't split up, so it just stays as it is. And these would be 2 LiNO3s. Now, I can put charges on them if I want to, but it's really not that important. But just for kicks, I will. All we're really interested in, though, is the number of particles that we're getting here. And this would be a total of 3. This would be a total of 4. That's a total of 1 because it doesn't split apart. And this would be a total of 4. So the sum of the coefficients would be 3 plus 4 plus 1 plus 4, which is 12. That would be the answer. But it's again, it's just a matter of figuring out how many aqueous ions we're getting, and then looking at the solid and just leaving it the way it is. Any questions about that from any of you? No questions?
No, of this.
Okay. Why don't you all try this one? Give this one a go. So we're looking at the full Ionic equation. Now remember that you draw out pictures of everything, but leave the solid the way it is. Just don't touch it. Just leave it the way it is. And let me know when you all are done, and I'll go through it.
You want the answer?
Yeah, what do you get? What do you get, Anna? I think we
I
wrote
say
that.
15.
You get 15. Let's have a look. We'll see how it goes. So FeNO3 3,
Mm-hmm.
and that's how that would look. And then we've got Na3PO4.
Wait, no. No, 3. Oh, yeah. PO4, 1. Mm-hmm.
We've got FePO4 solid, which stays the way it is.
Mm-hmm.
And then we've got 3 NaNO3s.
Mm-hmm.
So we've got 4. We've got 4. We've got 1. And over here we've got 6. So the answer would be 8 and 7 is 15. I think that's what you said, right, Anna?
Yes.
All right. Kayla or Ashley, did you have any questions about this one?
I actually got it. I mean, I'm not as fast as you guys, but I got, like, clearly in my mind, I have that concept down. So
Okay, that's great. I think actually the main thing I can tell you, just be careful of that solid and don't split it apart. That's where most people make their mistake on this one. They try and split that solid apart. Just leave the solid the way it is, and everything will work out fine for you.
Okay.
Okay. This is for the net ionic. So what I'll do is, by way of introduction, I'll show you exactly what the net ionic is. In the net ionic, I'm going to go ahead and put charges on here just to make it a little bit more clear. The net ionic generally comes from the full ionic. But the concept is that if you've got 2 of the same things on each side, then they can cancel out. And you can see here we've got 3 NO3 negatives, and we've got 3 NO3 negatives over here. They can go 3 Na pluses and 3 Na pluses. Those can go, those can cancel. All we're left with is Fe3 plus PO4 3 minus gives FePO4 solid. And the sum of coefficients would be 1 and 1 and 1 is 3. So what we're doing there is the Na plus and the NO3 minus, they're called spectator ions. They appear at the beginning and they appear at the end, and they appear unchanged. So just like in any mathematical equation, when you've got like terms on each side of an equal sign, you can get rid of them. And that's exactly what we're doing here. But if I'm looking at this next one over here, number 27, it becomes a little bit simpler than that, because you're only interested in what's making the solid. And that's all you have to focus on here, what's making the solid. And to look at that solid, you see that it would be, if you're looking at the solid, you can see that the solid is just Cr2SO43. And you're asking yourself, well, what would form that? Well, actually, I'll put you on the spot here. Tell me how many chromium CRs you need to make that solid. How many do you think you'd need? It's not a trick question. How many CRs do you see there?
2.
2. Yeah, all right. How about SO4s? How many SO4s do you see?
I see 3.
3. Oh, gosh. Well, you can put some charges on here too. We can make that 3 plus and 2 minus. But you see it goes 2, 3, and then 1. What do you know? A total 6. See, you know that the Li and the Cl are all just going to cancel out anyway. So it doesn't really matter. All you're interested in is, oh, what's making the solid? Oh, just a chromium and the sulfate. So it makes it pretty easy, doesn't it? You just look at it that way.
The Li, say that again?
Yeah, the Li and the Cl are just going to cancel out, because that's what forms the LiCl, and that's going to just be Li plus and Cl minus anyway. See, it looks like this. And you can see here the Li's all cancel and the chlorines all cancel. And that's how we come up with it. But we know that they're going to cancel because they're not part of a solid. We know that anything that's going to be aqueous on each side is just going to cancel out. So we're just going to be left with those things. It's the chromium and the sulfate. Enough to make up whatever solid we have.
You're saying we're only left with, can you hover over the test and say it again?
So you've got the chromium, 2 chromiums here. And we've got 3 sulfates. That's all we're left with. And of course the solid here. And the Li pluses and the Cl minuses all cancelled out because they were the same on each side actually.
Okay. 6 LiCl and 3 Li2SO4, 3 times 2 is 6.
That's right. You can see, but you can count them here too. Look at them. 1, 2, 3, 4, 5, 6. If we draw this out 3 times, 3 Li2SO4s, we end up with 6 Lis in total. Likewise here, 2 CrCl3s will give you 6 Cl minuses in total.
Okay.
Is that all right?
Mm-hmm.
Okay. You give this one a go. There's actually a couple of acceptable answers for this one, and I'll go through why that is in a second.
This it will be 6.
6 or 3, Anna, actually. I'll show you why it might be, 3 is also an acceptable answer for this one. If I drew it out, 6 is fine though. Look like this. I'll put it as charges on as well.
Why are we only drawing out 2 NO3s?
For which one?
You drew out 2 AGs. Why are we only drawing out 3 NO3? I mean,
Because 2 times 1 is 2. You have 2 NO3 in the beginning. Because
Yeah.
you have 2 AG, but you have 1, but you need to multiply.
I think actually what you're asking is, well, look at the NO3s here. If there's only one of them in the compound itself, there's two total here, but there's only one NO3 in each AgNO3 compound. There's not 3 there. If there were 3, it'd be in parentheses. It'd look like this. That would have 3 NO3s in it. Do you see what I'm saying?
yeah,
I think that might be what's confusing you. Is that right?
that's 100% correct. So what is this?
Okay. But there's just one NO3. And the reason you know that is just look for the parentheses. No parentheses, there's only one of them.
And what does the 3 mean?
Well, it's just part of the NO3 polyatomic ion.
Okay.
It's just one, but there is just one of them. That's all. In each instance, of which there's 2. There's 2 AgNO3s. So that's how I draw it out. Now these cancel. The NO3s cancel and the CAs cancel, and all we're left with is just the others. So it'd be 2 and 2 and 2, which is 6. But because this could balance out, 1 and 1 and 1 is equal to 3. That would be fine too. It's the Ag plus, and if we just divide everything by 2, and AgOH solid. So that would work as well.
So at this case, can you count the charge? Just the charge of the element?
It doesn't really matter. It's all that matters is how many of each you have. But 6 or 3 would be fine answers, Anna. Either one.
Okay, but I want to understand why 3. It's just because it's one element, or
No,
for
no,
what reason you put 1?
no. I think it's mainly because of this. I'll show you. Because you could, if you wanted to, you could divide that whole reaction by 2 and come up 1, 1, and 1.
Okay.
That's really.
Okay.
And in this specific question, if you answered 6 or 3, you get 100% and it'd be fine.
But Professor Richard, if you want to divide, for example, the another equation have another number, for example, 3, you cannot divide just with the.
Mm,
Okay.
You're right. Yeah. It's only in these kinds of cases where you've got, the same number on each, but you could divide through by that number.
Okay, understand.
Okay. Any other questions about the full ionic or net ionic equations here?
Can I ask, so basically with these problems, you need to write it first write it out.
Yeah, draw the pictures.
Write it out. I guess I'm talking about like each little tiny step.
Yeah, that's fine. Yeah,
write it out.
Mm-hmm.
Then when you write it out, put your charges.
Mm-hmm.
And you get your charges from either the polyatomic ion sheet or the periodic table.
Mm-hmm. Mm-hmm. But don't separate out the solid. I think that's you should add that.
Yeah, I got that. Trust me, if it's not a step, I got that part.
Right.
So okay, then basically leave the solid alone.
Mm.
Because here in the solid, we just counted 2, which is right in front.
That's right.
And then if you were discussing canceling,
it's just whatever's exactly the same on each side.
So why wouldn't you cancel 2Ag?
Because the AgOH forms a solid, which is different.
Oh, that's right. You don't even look at it.
It's different to the Ag plus and the OH minus. So it's a good question, though. I'm glad you asked that, because that really is the key to understanding why that doesn't cancel. Yeah. Because it doesn't split apart.
Okay, so then I get the canceling just because that's.
Then all that's left is what you're counting: 2 Ags, 2 OHs, and 2 AgOHs. 2 plus 2 plus 2 is 6.
Now, is this rationale / thought process just in these right here? Because remember how like in module 5, I don't remember.
No, I think just for these here, I'd say. But then again, here we're dealing with actual full reactions, where in module 5, we were just dealing with individual compounds.
Okay. All right. I like that. Thank you for going over this. This helps. This one helps a lot too.
Yeah. All right. Let's. There's one more question I want to go over, and that's this. Well, actually, 2 questions here.
Oh yeah, I was going to email you about this last night. Okay.
Well, you don't have to now, do you?
Yeah, I figured. Let me just wait.
All right. Let's take a squiz at this one. A squiz is a look, by the way. Let's have a look. So for a compound, so a question like this, number 29, the X here is an imaginary element, right? It's something that doesn't exist, but it could hold any charge from 1 to 6. Now, the nature of this reaction, either the ClO3, I think there might even be ClO4s as well. But if it's XClO3, it's always going to give XCl plus O2. So those are always going to be the products. Same if it's XClO4, it's going to be XCl. This is unbalanced. Would be plus XCl plus O2. So let's apply that to what we're doing here. If I draw a picture of this, we know from the polyatomic ion sheet that chlorate, or ClO3, has a -1 charge. That means that X has a 5+ charge over here. So it becomes X5 plus and then Cl minus plus O2. And that would be XCl5.
Professor,
So,
where are you getting this from? Where are you getting XCl3, 4, then the XL plus O2?
this is, all right, this is just background, okay? I'm just telling you that these compounds always form a chloride and O2 as products. Every single time, actually. Now, we've got to figure out what that chloride looks like, but we're also getting O2 as well. Now, what I did there was I drew out the XClO3 because that's what we're given here in the problem, to figure out what the charge on the X was, and then to figure out what the chloride would look like. It's kind of similar to what we did at the very beginning with those acid-base problems, how I had to figure out what the compound was before I balanced the reaction. You with me?
No, but
Okay, so just see if you can ask a question that would help clarify things. I mean, what I'm telling you here is prerequisite knowledge, but you'd have to know that a chlorate or a perchlorate would break apart into a chloride and O2. I'll just finish this off here. XClO3 gives XCl5 plus O2. And then we would need to balance this out. And this one's a little bit tough to balance because we've got 15 oxygens over here and only 2 on this side. So I know if I put a 2 in front of here and a 15 in front of here, I could balance the oxygens. And then I put a 2 in front of here, and the answer here would be 19. But if we look at the steps here, if we just break it down, the first thing we do is try and figure out what the charge on the X is. And just a tip here, it's always going to be the same as the number of ClO3s attached, in the compound. So that you can see that it's 5. You automatically know X is going to be 5+. Then you figure out what the chloride would look like. And that would mean that we'd need 5+, which means we need 5 Cls to match that. And then we have to balance the reaction here that we get. And the reason I knew this was 15 and this was 2, 15 times 2 is 30. That's going to be my common amount here. So I put a 2 in front of here to give 30 oxygens, and 15 times 2, that's 30.
You're saying 2 times 3 is 6, and 6 times 5, and 6 times 5 is 30?
No. 3 times 5 is 15. 2 times 15 is 30.
Okay, I just want to know the order. Okay, thank you.
Yeah. Well, if you count them up here, you can do 3 plus 3 plus 3 plus 3 plus 3. That's 15. See the 15 oxygens?
Yes.
But you've got 15 versus 2. So there's no real way that you can balance that except by multiplying this by 2 and this by 15. It's kind of like if you're finding a common denominator, like between 3 and 2. The only way you can do that is multiply 3 and 2. Give 6. In this case, it's 15 and 2 is 30. I'll do another couple of examples of these.
What's the answer here again?
19. hang on, let me see if I can, there you go. You see? 2 plus 2 plus 15. 2, 2, and 15. That's 19. That would be the answer. I won't delete the whole thing. I'll leave the background there. Let's do another example. Let's say it was. I'll do a perchlorate. I'll show you a little bit of a. What's the charge on the X? Ashley, I'll ask you that. What's the charge on the X? If you know ClO4 has a -1 charge, you know what the charge on the X is going to be? And so it has to be 2 plus. And we know it's going to combine with Cl minus to give a chloride. And we're going to have oxygen O2 as a product. The compound would be XCl2 plus O2. And then we need to balance it. We've got 2 Cls, that's okay, 1 X, that's all right. 4 times 2 is 8 on the oxygens. Put a 4 in front of it. The answer there would be 6. 1 plus 1 plus 4. Anybody got any questions?
No, please.
Anna? Sorry, Ashley? Sorry, Ashley? Ashley might have left the building. Do one more.
Sorry, I was coughing. I'm just gonna have to watch this later. I don't know.
Is there anything, I don't know, what else can I tell you about it that would help, Ashley?
I honestly don't know.
Okay, I'll do one more example here. So let's say we got XClO3, 3. It would give X3 plus, Cl minus, plus O2. That'd be XCl3 plus O2. We'd have 9 oxygens on this side, so put a 2 in front of here and a 9 in front of here to balance that. Stick a 2 in here. The answer there would be 13. So that's the basis of it. That's how we're coming up with those answers. All right. Okay. Is there any questions about that? Okay. Let's look at number 30. Now, number 30. Sorry, go on.
Professor Richard, I have a question about that. When, for example, you put magnesium with another component and that did just change the color but no heat, and this is reaction or no?
Yeah, it's reaction.
Doesn't matter if don't have bubble, just have a little. You have some in one of the videos, you put magnesium with another, I don't know, remember what is the solution, and that the magnesium just puts a little bit dark. So this would be the reaction.
Yeah, that'd be a reaction. So anytime, if there's no changes, there's no reaction. But if you got anything else in there, then there is a reaction.
Doesn't matter if the magnesium will be the solution or not.
We'll say it again, please.
Doesn't matter if the magnesium will be, disappear or not disappear. Just for change the color, have the reaction.
Yes,
Okay,
anytime,
okay.
yeah. But as a general rule, if you're looking at this problem, anything in there that doesn't say no changes is you should interpret as a reaction.
Okay.
So the idea here is that if we've got a metal that's a solid and then a metal that's part of some sort of aqueous solution, we'll leave it as nitrates. We know that this is Y is going to be some sort of plus charge. Then we've got X, which is a zero charge. And then the reaction, if it occurs, would be Y solid plus X NO3. So then the Y becomes 0 and the X becomes a positive charge. Now this reaction will occur when X is more active than Y. And it won't occur when Y is more active than X. So what we're looking at here in the problem, we know if the reaction's occurring or not because we look at the observation. So if the observation says no change, then we know there's no reaction. So that tells you what's more active. So really what you have to do is look at this Fe plus KNO3 and figure out, well, which one's X and which one's Y. So the Fe being solid, that one's going to be your X, and the K is going to be the Y, because that's part of the NO3. So we're looking at that, and I can say, well, there's no reaction, so which one's more active, the K or the Fe? And that's it's going to be the K, because there's no reaction. That's what you need to know for this one. So looking at the filling in the blanks, is there a reaction? The answer is no, there's no reaction. The neutral element, well, that's one without the charge. That's going to be the Fe. The cation, that's going to be this one here, the Y, which is going to be the K. That's K plus. And the more active one will be the K, and the less active one will be the Fe. So you choose choose the answer that fits that. So it's not really that bad. It's just a matter of knowing when the reaction, what happens when the reaction's occurring and what happens when the reaction is not occurring. So any questions about that? I will do another example. Any questions about number 30?
Oh, it's going to be no.
It would be
Fe.
no Fe, then K plus, and then KFE, Ashley. It would be this answer here. I'm putting the check on here. That would be the answer. And again, you know that K is more active because a reaction did not occur. And we know that from the observation. So you always know when a reaction is occurring and when it's not occurring.
Okay.
All right. Do you have any other questions about that, Ashley? I'll do another example. Okay, so for this one, what do you think? Do you think there's a reaction or not there, Ashley?
I have no idea, Dr. Musgrave.
Okay,
Hard
well,
reaction.
yeah, you can tell by looking at the observation. If the observation is anything but no changes, then there's a reaction, Ashley. If there's no changes, there's no reaction. But if there is anything else in there, then you say yes. All right, so the answer there is yes.
But I don't understand, like, oh my God.
If it said no changes, then you could say no reaction. But if there's anything else in there, then you can say, but there is a reaction.
Yes, sir, but where, like, what are you looking at? Like,
It is here, the observation. See where it says Na dissolves? Circling it here.
well, if any dissolves, then yeah, okay.
Right. If it said no changes, then you'd say no reaction. That's what happened in the last one. It said no changes, so there was no reaction. So you with me so far?
Yeah, now I'm with you. Okay.
Okay. Now the neutral element, what do you think that is for this one here? This reaction we're looking at.
Would it be Na?
Yeah, that's right. So Na is a neutral. What's the cation?
The cation would be Cu.
Yeah, and we'll make it 2+ because there's 2 nitrates. You don't really need to know that though, because you can look at the answers. You can see what the charge on the copper is there. So which one is more active? The Na or the copper?
Copper.
No, it's when a reaction occurs, the X is more active than the Y. So the Na would be more active than the copper. It's the opposite of the last one because there's a reaction this time.
Okay, that helps a lot. I wish you knew how long I've been working on that. Okay, that was real clear. That was a good comparison between the two problems.
Yeah, well, they're opposites. You know, these two are flipped at the end because a reaction occurred.
We get more than one piece of paper on this exam, right?
No, I think you just need the one, but you can use a couple of blank pieces if you want.
Okay.
As long as you show them on the on the thing, right? The room scan. I think 2 would be the maximum you'd need. Actually, I can't imagine needing more than that.
Okay.
All right. So does anybody have any other questions they want to ask?
Do you know around what time this Zoom will be available?
Oh, I hope within the next hour.
Okay. Okay. Cool.
Yeah, I mean, I'll try and get it up as quickly as I can.
No worries. No worries. Okay.
Yeah. But I know that you had wanted some other help. So if you want to schedule a time with me by yourself, we can do that too. That goes for any of you.
I did the practice test. It's just so many steps, and I feel like every other problem something does or does not apply, which is really confusing me. No matter like, I don't know, like.
It's all practice.
It's all practice. That's what I'm doing. It's all practicing, knowing what it's really knowing what you're looking at.
That's right. Knowing what to ignore, knowing what you need to look at. Yeah. And once you get it straight, it's not too bad, but it can be a bit messy initially. All right. Well, we'll leave it there. If anybody needs any extra help, contact me by email, and that goes for anybody who's watching this Zoom as well. All right. Okay, we'll leave it there for today. I appreciate your coming, and I'll see you all later.
Thank you,
Thank
Dr.
you.
Mansfield. I'll email you in a few hours.
Yeah, no worries. Thank you. Bye-bye.